Hey, what's going on? I'm still making this baseball game, and I'd like to get to the point where I animate the ball. So right now, we've gotten to this point where if I press start and then I press pitch, the pitcher goes through his animation and he leaves the ball on the screen. I'd like to animate that ball. I'd like that ball to just go from the right to the left in a straight line. It'll take a little while to get to adding gravity in here. We will do that, but not right now. The drop is actually significant in baseball, so we will get to that point. I'm not going to get there right away. First, what I'm going to do is I'm going to just add a velocity and update the velocity and make it go. That's about it. But that's the first of our actual physics, all right? And this is going to be sort of a Newton's method idea where we'll update every single time how far we go. And eventually there'll be a lecture all about that online that goes with the game. Right now I don't have that up, but there will be one eventually, and that will talk a little bit more in detail about the theory behind it and all that other fun stuff that I know you love, all right? But first I just want to do it. I just want to do this game this summer, right, and get it all done, and I don't need to worry about sitting around and getting the theory correct and understandable for you. So I'll just show you how to do it, and hopefully that'll be sufficient. All right. So right now we have this ball, and it's got a radius and a position. If it's going to move, it's going to need a velocity, and it's going to spawn with an initial velocity, right? Self.vx equals velocity 0. Self.vy equals velocity 1. I could use a set function for that, but I think I will just use this. There are some advantages for the set methods, but I don't think I'll do that. Now, I've got a velocity. What am I going to do with it, right? I'm going to have to update it and make it move. So that means I'm going to have another update function. Okay, and as you recall, that update function requires an interval. It requires the amount of time between this step and the last step, and that's going to be in seconds. So I think I went through and I modified this so that's in seconds. I've already done that for the boilerplate. I did that previous to doing that in the other thing. So that's why I was a little confused earlier, is I'd already done that elsewhere, and it hadn't trickled into this. Wherever it was I got this original boilerplate from or whatever, I may have done it a little bit earlier than I did that, and so forth and so on. Anyways, how are we going to update the position? Well, how you update the position is fairly simple. You just take the old position, and so that's self x, and you add to it plus equals the velocity, self vx, times the interval, right? So the velocity is in meters per second, or feet per second in this case. And if it's in feet per second, then that means that you're going to want to multiply that feet by a number of seconds, and that'll tell you how many feet it goes in that number of seconds, as long as it's a nice uniform motion. And that's what it is. If we haven't added gravity, there's no force on this. We're not even going to bother with air resistance in this, unless I change my mind later. But if we do that, that'll be way out later. That'll be the last thing. That's all I need to do to update that. Now, what else? What happens else? What else do I need? I actually don't need anything else. I just need it to change its x position. I do need it to change its y position eventually, but not yet, right? Because I haven't added the gravity. Without gravity, if I just send this off with a horizontal velocity, which I assume a good pitcher does, and maybe that's not true. I'll go talk to pitchers. If I just have a nice horizontal velocity, it will go in a straight line and everything will be awesome, right? So that's all we want to do, is just make it go in a straight line. The first part of the physics is all one-dimensional, so we'll just live with that. If there are any changes that we have to make later on If pictures usually have a little bit of an up velocity or something, we'll add that later on. But I don't think that's the case. So I will go ahead and use that as our update function. That's all we really need, I think. So that means, though, that when we create our ball, right, since I have got this velocity in there, I have to give a velocity to it. So my throw ball is going to need a vel as well, okay? And vel is going to be equal to vel x comma 0.0. That makes it a floating point number, and somewhere down here I have a calculator, and let's throw it at 90 miles an hour, okay? So 90 miles an hour, 1 mile is 5,280 feet, and 1 hour is 3,600 seconds. It seems like a lot. Let's use 132. 1 mile, yeah, okay. So let's give it a vel x of 132 feet per second. Still looks like a lot. We might have to slow that down. But now we should have absolutely no problems when we create the ball. Right, start, pitch, no braking. Issue is we haven't told the ball to update, right? That has to come from the engine. The engine does that sort of stuff. So if we come down to the engine, we've got the avatar doing something, but we need something for these objects, right? So however many objects we have for object in objects, object.update. So now for everything except for that picture guy, everything just updates, and it needs an interval, like I just said. But the avatar keeps track of whether or not the ball is thrown. If the ball is thrown, it goes down there, creates the ball, and all that other fun stuff happens. And this will get the ball moving right away. So it'll actually, yeah, it'll get the ball moving right away. So that should be fine. All we have to do is make sure that we send those objects to the engine. We called those objects other stuff. Other stuff. And let's see if that is enough. Oh, I put it in the wrong direction. That's one issue. All right, so let's go down to, let's go back up here to ball. Let's see, what do we, no, we don't need ball. It's where we actually put it in here. Minus 132. All right. And why did it keep cycling through? If state is, so it just kept on making more buttons, or more of these guys. So let's see what happens. Okay. So that is a fast ball. That's 90 miles an hour, but at least I can see it on the screen. I'm not sure exactly how many things it does, but it goes through the screen, and possibly you'd be able to do something. Now there is an issue here, and you're not seeing this, right? Because I didn't do something else. But let's come back down here and just keep track of how much stuff is in that other stuff. So I'm going to use this output region out here. Mostly it's just saying that I'm running something and I stopped running it. So let's just, after the result, print other stuff. I could print it all over and over again, but you'll get the idea here, and it won't clutter up the screen as much. So what I'm going to do, no, that's not what I want to do. All right, and now I can resize my screen. Resize my screen as much as I want, and I want it small. Okay, so, but I want to see my buttons. All right, there we go. All right, so now if I start and pitch, you see I've got one ball there. Now if I start and pitch again, it's got a second ball. And if I keep going on with this, it just keeps those balls in play. Even though they're going off in that negative direction forever and you'll never see them again, which is not true. Sometimes I've had things go off in a negative direction and they come back. I don't know why, and I don't really want to figure it out. But, they're going off in a negative direction. You should never see them again. And, eventually the program should run out of negative numbers and it should just break. But that could take a while. But we need to get rid of these things when they go off the screen. Okay. All right, so that's something else that needs to go in this model part. So the question is can I do it in the engine or not? So in the engine, I send this other stuff there, so I can, right? So I'll do that there. That's part of my that's part of what I do, right? I already send the field there. So the question is if the if field contains the object, then I'm fine, right? But if it does not contain the object, then I want to remove it. So I add that to a remove list. Okay, actually I don't like object. There's a reason why I use thing. It's because object is a special word in Python. It's a type. And I don't want to rename types in case I need them and all of a sudden the program thinks I've got something else. So I need that remove list. It's going to start off with 0. So here I've been adding things. Now, for everything in the remove list, I want to objects.remove that thing. All right, and now when I run it, it should get rid of those extra balls. So we don't want extra balls. We just want one ball at a time. We don't want 7 balls running around making life hard. So no extra balls. That's our motto. So let's start and pitch. And I broke something. All right, and the ball has no instance get position. So if I come in here in the field, I had that contains method. That requires that the ball have a method that sends the position to the call to that to wherever the program wants it, and so that means I have to create that get position method. Get methods and set methods are sort of a standard way of using classes and objects and things like that. So now it does that thing. I reset, send it again, and you can see down there, rather than having a whole bunch of different balls, there's only one ball at a time. And I'm not monitoring it, but as soon as it goes off the screen, that that ball disappears. There's nothing else that can be done with it. The next ball has to come from the pitcher, and that's basically the way baseball is played. You don't get to use any balls except after the pitcher throws them. So the last thing I want to do is I want to go down here and get rid of that print statement because I don't need to track it anymore. And then that's about it. I've got the working ball, so my balls are working, and I can play with them all day. If you'd like to get to the next part, that is going to take me a little while. I'm going to be running off and going to cities and things like that, and also I have to do all the animation, and the animation is the boring part. But I have to do all the animation for the batter. So it might take a couple weeks to get to the next one. But other than that, thank you. It's been very nice talking to you today.